Hi, welcome back.
GATE ESE, Electronics and Electrical Engineering.
I'm welcoming you all to this beautiful online learning platform, Unacademy. All of you know that Unacademy is the India's largest online learning platform. So I'm welcoming you all to this beautiful online learning platform. And now we are happy to announce that we started the GATE and Engineering Service Examinations training. The students who are appearing for these examinations, we are providing online training to those people. Okay. Now, India's top educators are going to handling your classes in live. Okay. Now, about myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada. My specialization is VLSI design. First, we check how to get Unacademy learning app into our device. For that, just go to Play Store in your device, install, just type Unacademy in that. By typing Unacademy in that, it will install the Unacademy learning app into your device. Okay, in this, just click on this install button. By clicking on this install button, it will install the Unacademy learning app into your device. Okay. Now, once you open this app in your device, it will show what are the different courses available in this. And each course handled by which faculty, and you can view that faculty information also. And here the faculties are top educators who are already success in their competitive examinations like GATE, engineering service examinations, and the faculty who are having the vast experience. Okay, so those are the faculties handling the subjects here. Okay, now so I am welcoming you all to this platform. Please once think of it, how much important it is. Okay, now here I am going to showing some of the top educators from Unacademy. Tiwari sir, he is the IIT topper, and Ankit Goyal sir, he got 2 times All India first rank. Okay, 2 times All India first rank in electrical engineering. Okay, and Jaspal Singh sir, he is the ex-IAS officer, he got All India 4th rank. And Sanchit Jain sir, he is the top faculty in computer science and engineering. He has a vast experience in computer science. Now here are the few more top educators working under this. Okay, now the few of the top educators who are working under Unacademy. Okay, now we are happy to announce that we started 2 new batches for GATE, one for GATE 2022, other one is for GATE 2023. Okay, now there is a Ascend batch for GATE 2023 for mechanical engineering. Yeah, this batch started from 22nd February 2021. Okay, here are the top faculty who are handling the subjects in that. And during subscription, don't forget to use my code VRAO10 to get 10% discount. And now we move to the Evolve batch. This is for GATE 2022 for same mechanical engineering. This batch started from 22nd February 2021. Here are the top faculty who are working under this. The same faculty who are handling the subjects of GATE 2023. The same faculty are going to handling the subjects. Okay. Now, here move to, there is a Spark batch for GATE 2022 for civil engineering. This is only for English batches. Is that English batch? This batch started from 22nd February 2021. This is for civil engineering. And one more important thing, there is a DDR, mission DDR for mechanical engineering students. This batch started from 22nd February 2021. Here are the top faculty who are working under this. Tiwari sir, Uma Maheshwara sir, Meenu Gupta ma'am, Aman Raj sir. Here are the top faculty who are working under this. Okay, and this batch started from 22nd February. So please join. Don't forget to use my code VRAO10 during subscription. Okay, by joining this code you get 10% by using my code in this batch. Next one is there is a Ascend batch for GATE 2023 civil engineering. This batch started from 8th February 2021. These are the faculty who are handling the subjects in this. Okay, now don't forget to use my code VRAO10 during subscription to get 10% discount. Next, there is a Eval batch for GATE 2022 for civil engineering, and the same batch who are handling the GATE 2023, the same faculty are going to handling the subjects for GATE 2022 also. This batch started from 8th February 2021. So next, there is a computer science and information technology. There is a Eval batch for GATE 2022. This batch started from 8th February 2021. So for your kind information, Ravindra Babu sir and Sanchit Jain sir are the top faculties in computer science. You can take any IITs. Okay, in that IIT, more high number of percentage of students are the students of Ravindra Babu sir or Sanchit Jain sir. Okay, so they have that reputation, and so they have that much command on these subjects. Okay, so throughout India, so that much number of people are going to be believe on them. Okay, so because of that only, even though this much demand at outside for computer science and information technology, okay, because of getting so many requests from the students, we started this batch. And Subbarao sir, Malesham sir, okay, and Sweta Kumari ma'am, okay, Vishwadeep sir. So these are the top faculties in this department. Okay. And don't forget to use my code VRAO10 during subscription to get 10% discount. Next, there is a Ascend batch for GATE 2023 for electrical engineering. Okay, and this batch started from 1st February 2021. Here are the top faculty who are handling the subjects in this. Okay, now in electrical department, in generally more number of subjects is there because of that more number of faculty. Okay, now we are moving to electronics and communication engineering. The Ascend batch for GATE 2023. This batch also started from 1st February. So these are the faculty top educators who are going to handling the subjects of electronics and communication engineering, ECE. Next, there is a Eval batch for GATE 2022 for electrical engineering. Here are the top faculty who are handling the subjects for this electrical engineering, and this batch started from 1st February 2021. Okay, now there is a again Eval batch for GATE 2022. This time this is for electronics and communication engineering. This batch started from 1st February 2021. Okay, here are the top faculty who are working under this. Now, so you believe it or not, this is a chemical engineering itself. Chemical engineering. You observed or not, at outside throughout India, hardly 1 or 2 locations only training for chemical engineering is available. Okay, hardly 1 or 2 locations throughout the India. But in most of the regions, we have chemical engineering subject. So the students who are studying chemical engineering at their locations, for them it is very difficult to move from their location to that location and attending the classes. In that view, they started the training for chemical engineering also by online. These are the top faculty who are handling the subjects in this chemical engineering department. They must thank to Unacademy because they provide such a beautiful facility to the students. No need to move anywhere, just by staying at their home itself, they can enjoy the fruits. And this batch started from 25th January. If any of your friends are in chemical engineering, please inform this one to them and please support them for their growth. Next, now we are happy to announce that now there is an academic combat is going to be conducting. That means we are going to conducting a scholarship test on tomorrow 28th February 2021 at 11 a.m. at 11 a.m. and its worth is 85 lakhs plus. Its worth is 85 lakhs plus. Don't forget to use my code during registration VRAW10. Okay, by using my code, using this code you can register and you can write the exam. Okay, if you get the good rank, then you get more benefits from the Unacademy. Okay, don't forget, please put a remember in your mobile. It is February 28th morning 11 a.m. At 11 a.m. test is going to be conducting scholarship test. If you get a rank of 1 to 3, first rank to third rank, if you get a rank first to third. Okay, now you get complimentary Unacademy Plus subscription for the tenure of your choice. That means for 6 months, 1 year, 1.5 years, or 2 years, whatever you want. If your rank is top 3, you get a complete 100% scholarship. No need to pay anything. Okay, simply attend the classes. Now the tenure is either 6 months, 1 year, 1.5 years, 2 years, whatever it is. Whatever you want is your choice. Okay. So my dear students, please don't miss this golden opportunity. And if your rank is 4 to 10, now you get 75% of subscription scholarship. 75% scholarship. You need to pay only 25%. So here also same. You can take any tenure plus subscription of whatever the tenure you want. 6 months, 1 year, 1.5 years, or 2 years. Choice is yours. Again, if your rank is 11 to 50, you can take 50% of scholarship. You get the 50% of scholarship. Okay. Now 50% you need to pay, and if remaining 50% you get the scholarship. And if your rank is 51 to 100%, you get 25% of scholarship. All these are for plus subscription. Whatever the tenure you can take, either 6 months, 12 months, 8 years, 18 months, 18 months, 2 years, whatever it is. Okay. So my dear students, please don't miss this opportunity. Utilize this opportunity and crack it. Now, just I am going to refreshing what are the different engineering disciplines available from Unacademy for GATE and engineering service examinations. Mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, computer science and IT departments, chemical engineering, last but not least, electronics and communication engineering. Electronics and communication engineering. Okay, electronics and communication engineering. Now, there are two subscriptions available, Plus Plan and Iconic Plan. In Plus Plan is the basic plan. Plus Plan is the basic plan. In this, you get India's best educators are going to handle your classes. There are interactive live classes, structured courses and PDFs are available, live tests and quizzes are available. Okay, and in Iconic, it will take your GATE and engineering service preparation to the next level. It will take your GATE and engineering service preparation to next level. That is your Iconic plan. So in this, we are going to provide a personal coach to you. With the help of personal coach, We will take your preparation to the next level. Okay. Now you may ask one thing, sir, how you are taking my preparation to the next level? See, just by same thing, whatever the things here you are getting, same things here also, but here we are going to show the difference. Live tests and quizzes are there. See, in live tests and quizzes, here after completion of your examination, whatever your answer sheet is there, we will analyze from first point of your answer sheet to last point of your answer sheet. From that, we will prepare a note where you are strong, in which topics you are performing good, and in which topics you need more preparation, in which topics you are doing mistake. We will verify all these and we analyze all these. From the knowledge of that, we will prepare a proper study planner to you. Proper study planner to you. Okay, this study planner is going to support you. And with respect to that, we will provide proper study material to you. With the help of these two, any student can get success in their examinations. That is the intention to provide a personal. You observed or not, so many number of students are writing the examinations, but in that only very few people are going to be success. Why? Because there is a clear difference between the two people who are analyze once they done something, who are go back and analyze what the things they done. Okay, analyze that and what are the gaps in their work, what they done, what are the gaps they identified. They has to fulfill those gaps. Then they has to go for attempt for the next attempt. Then they are going to be success. Identifying the gaps in their preparation, your preparation is a very crucial role it plays in your success. So with the help of personal coach, we will fulfill those gaps. Because students are very busy nowadays. The third year, final year students, most of the cases, they are very busy with their semester examinations, assignment examinations, lab examinations. Okay, now recently one more new point came out, that is internship. Even summer also they have to attend do some internship somewhere, where they have time to prepare competitives and to analyze the examinations, all these things. So very few people are getting the time. So in that point of view, in that aspect, we are going to providing a personal coach to fulfill the dreams of the students. Okay, so my dear students, you just come and join in that iconic team. Okay, we will do that overall analysis and we will give a proper study planner to you. Just to follow the study planner, and what are the respective material you want, for that we will provide that material to you. Okay, and one more thing, India's top educators already we observed. Okay, so IES rankers, GATE top rankers, IIT toppers, well experienced faculty in the field, okay, are going to handling your classes. Once those faculty are handling your classes, you can say you can write the examination. Okay, we are taking the remaining part of the risk. You don't worry, just to follow us. Okay, now just we check the cost for each and every plan. Now there is a plus plan. The cost for plus plan is for 1 month subscription it is a 5,500, for 3 months 13,750, for 6 months 1 year, 1.5 year, 2 years. As a faculty, I recommend to the students take minimum of 1 year subscription. Why? Because minimum 1 year is required for a student to complete their preparation, and to repeat the subject number of times, and after repetition of the subject number of times, you need to write the examinations for topic wise, subject wise, and grand tests. And after completion of every exam, you need to analyze your examination answer sheet. Okay, how it is, you need to verify. Okay, and you need to identify the gaps in your preparation and you need to fulfill those gaps. And after that, with full of command, like a loaded gun, you need to attend the exam. That's why you need minimum 1 year. So my dear students, please once think of it. Its cost is 30,250 rupees. And if you are using my code during subscription, if you are using my code VRAW10 during subscription, you get it by 10 with you get it with a 10% discount. That is 27,225 rupees only. See, the cost, if you observe, it is 27,225 rupees. It is, for example, you joined somewhere at the outside to get the training. To travel for your transport from your home to the location where you are taking the training throughout the year. And one more thing, only training you are taking weekends and public holidays. Okay, for that duration, in that times, if you need to attend the classes. For that, worst case, if you calculate throughout the year, it is going to be minimum 20,000. Just by adding 4 to 5,000 to that, 20,000 plus you get. So by adding 4 to 5,000 to that, you get the complete training. By staying at your home itself, by sitting at your home itself, you can get the more benefits. No need to move anywhere. Just stay at your home. Stay at your home. Get the benefits. That to more than that benefits. Your classes are handled by top educators. Okay, interactive live classes are there. Continue examinations are going to be conducting. What not? Everything you get. Okay. So, my dear students, please once think of it. And before going to taking a decision about these things, you contact once your parents and discuss about the benefits what you are getting here. Okay. And once meet your faculty who are having knowledge on the GATE and service examinations. Okay. Take the right decision. Okay. Now we move to iconic plan. This iconic plan is available in two subscriptions. One is a 1 year subscription, second one is 2 year subscription. For 1 year subscription, it is 50,250 rupees. For 2 year subscription, it is 74,000. 74,000. Okay. Now, for 1 year, by using my code VRAW10, you get it by 45,225 rupees only. That means you get 10% discount. And already I told, here we are going to providing a personal coach to you. Because of that only we are charging this amount. Okay, providing personal coach is not that much easy. His work is too much. Okay, every day, every week he has to give the report of your progress. Okay, once they give the progress, from that previous progress to this progress, we will verify the variations and student status, how they are preparing, how many hours they are going to be preparing, is there any doubts, any more doubts to the students, is the topic is completed or not, respect to topic what they are expecting the student, or what is required to the student, is it completed or not. Everything is going to be noted and properly planned. Okay, so my dear students, please once think of it and take the right decision. That decision will set your life at a good position. Okay, now thank you. Now don't waste time, enroll today, don't waste your time. Now I'm moving to our topic, transistor CE characteristics. CE in the sense common emitter characteristics. Okay, so we know that in a transistor we have three terminals: emitter, base and collector. Three terminals we have. Okay, now just before going to this topic, just 5 minutes we rewind the current components of the transistor what we completed, because that knowledge is required to understand CE characteristics effectively. Okay, and after current characteristics we go on discuss about the base width modulation. Those two topics are required to understand CE characteristics effectively, because CE characteristics is very important to bias your transistor properly. Okay, to bias your transistor properly. Once your transistor is biased properly, then only you can design your amplifier from that. Okay, so you can design your amplifier from properly biased transistor. That's why you should be thorough with this transistor bias, transistor current component first. Okay, now I'm going to transistor current components. Now, transistor current components. Transistor current components. Say this. See, we know that default region of operation is default region of operation of transistor is in active region. Okay, default your transistor is going to be operated in active region. What is the meaning of active region? Active region in this sense, in transistor we have two junctions. We have two junctions. Just see this. So let us, I am taking PNP transistor here for better understanding of the, for better understanding I am taking PNP transistor. Now emitter, base and collector. This is a PNP transistor. You observed or not? Here there is one PN junction, another PN junction. So two PN junctions are there. So first PN junction is between emitter to base, second PN junction is between collector to base. Simply I call this one as emitter junction and I am calling this one as collector junction. Two junctions. Now active region in this sense, whatever the junction between base to emitter or emitter to base we have, we call it as emitter junction. Now that emitter junction is going to be under forward bias and that collector junction is going to be biased in reverse bias. That is the active region of operation. So once the junctions are operated like this, then we said our transistor is in active region. Now I am going to operating my transistor in active region. For that, so this is going to operating in two ways, two steps. In first I am going to step one in this open circuit and collector junction is reverse bias. Collector junction is reverse bias. Okay, now I am going to doing like that. So it should be reverse bias. So N connected to positive, P connected to negative. Now your collector junction is under reverse bias. This voltage is VBC. So once junction is under reverse bias, I am expecting the movement of minority charge carriers. Here minority charge carriers are holes which are available in N region. Holes will move this side and in p region minority charge carriers are electrons. Electrons will move this side. Once electrons are moving from p to n, current due to this electrons will move opposite direction. Let us, I am calling that current is ip naught. And once holes are moving from base to emitter, base to collector, now current also moving in the same direction. That is, let us take it as in naught, sorry, this is in naught, sir, because due to electrons. Now I am calling it as ip naught. Okay, so I n naught, this is ip naught. Now both the currents are in same direction. Now I am going to representing this one by a single current, representing it by a single current, that is ic naught. So now ic naught is called as reverse saturation collector junction current. It is very important, sir. Reverse saturation collector junction current. Reverse saturation collector junction current. Now if you observe one thing, this current is flowing from, seems to be base to collector, but according to standards, a conventional current direction for ic naught should be, it should flow from collector to base. But compared to the conventional one, the current, regular current, general current is flowing is opposite direction. Because of that, we take ic naught is negative for PNP transistor and is positive for NPN transistor. So negative for PNP transistor and positive for NPN transistor. Anyway, from the result of step 1, we observed ic naught is flowing from collector to base. Okay, collector to base. Now I am going to redraw that. So redrawing this. So this is the result of step 1. So here this is the collector base and it is the collector. It is going to be operated in reverse bias. Operated in reverse bias. So a PNP transistor it is. So once it is PNP transistor, it is positive, it is negative. So this is the VBC. Now the result is current is flowing from this side. IC naught is flowing this side. And one more thing, this is the base current is flowing this side. Collector current is flowing this side. According to conventional standards, all currents should flow into the device. According to IEEE standards, all currents should flow into the device. So this is the emitter terminal. So emitter current is flowing into this, through this, base through this, collector also through the device. Now it is emitter is open terminal, because of that emitter current is 0. Result of step 1 is emitter current is 0, and by applying KCL at this node, IC is entering, IC naught is leaving. So we can write IC value is equals to IC naught. These are the results of step 1. So from step 1, what we gain is emitter current is 0 and collector current IC is equals to IC naught. Collector current IC is equals to IC naught. Is it okay, sir? Now we are moving to, now I am going to step 2. So that is the result of step 1. Now I am moving to step 2. Step 2. So in step 2, what are the two junctions we have? Emitter junction is in forward bias and collector junction is in reverse bias. Collector junction is in reverse bias. Emitter junction is in forward bias and collector junction is in reverse bias. Okay. Now, so emitter junction forward, collector junction is reverse. So now I am going to draw this. So for better understanding, I am taking regions little bit more wider. Yeah. Emitter it is. Center one is a base and it is collector. And PNP transistor. PNP transistor. Fine. So emit already just before we completed. See here you need collector junction should be in reverse bias. So if collector junction is under reverse bias, we know what happens. So here IC naught current is flowing this side. This is the result of connecting collector junction in reverse bias. So this is the IC naught. Now leave it. Now your emitter junction is also in forward bias. Now it is operating. Now just connect it in forward bias. So I am connecting this one in forward bias. Forward bias means P connected to the positive terminal of the battery and N connected to the negative terminal of the battery. This voltage is VEB and this is VBC. Okay. Now, so once P connected to emitter, N connected to, P is emitter, it is connected to positive terminal, N connected to negative terminal of the battery. That means your emitter junction is under forward bias. That's what we need here. Emitter junction should be operated in forward bias. Should be operated in forward bias. So once it is operating in forward bias, we can expect movement of majority charge carriers. Once they are in forward bias, we can expect movement of majority charge carriers. Okay. Now I am going to operating that in forward. So I am taking the movement of majority carriers. So here majority charge carriers in P region is holes and in N region majority charge carriers are electrons. Now holes will move this side. Once holes entered into N region, already we observed in a forward biased PN junction diode what happens, already we know that. Once holes entered into a N region, by drift they entered into the N region. Once they entered into N region, they diffuse in the N region. During diffusion, they are going to recombine with the electrons in the N region. So recombination taking place. After that, once holes are available in N region, due to collector junction reverse bias, holes has to move from base to collector. Just we check previous one. Yeah, check this. What are the holes present in N region? They are moving from base to collector. They are moving from base to collector. Now they are going to moving like that. They are going to moving like that. See this. Now holes are moving like this. These holes are entering into collector region. Okay, already we know that. So if emitter is giving 100 electrons, oh sorry, 100 carriers, in that very few carriers, hardly 4 to 5 carriers are recombined at base. Remaining 95 carriers reach the collector. This is base, it is collector. 95 carriers reach the collector. So few recombination is taking place. Okay, and the same way electrons are moving this side. So now once carriers are moving like that, immediately we get the current due to the movement of that carriers. Electrons are moving from N to P. Now there is a current from P to N due to this movement. That current I am taking it as, let us take it as INE. INE. So now holes are moving from P to N. Now the current is IPE. IPE. Now recombination is there. So recombination current IR. Recombination current IR. And once recombination is there, so the remaining 95 carriers entered into the collector region. Due to this, we get some collector current, that is IPC. The current entering into collector region is IPC. Okay. Now, what are all these things? And at the same time, terminal currents I am giving. This is the emitter current, base current, and it is the collector current. Okay. Okay. Now, first I am representing IPE. IPE. IPE is the whole diffusion current at junction, at emitter junction. Whole diffusion current, whole diffusion current at collector junction, sorry, at emitter junction. At emitter junction. So JE means emitter junction, sir. JE, emitter junction. And JC, collector junction. Collector junction. JE, emitter junction, and JC, collector junction. IPE, whole diffusion current at emitter junction. Next, INE, electron diffusion current at emitter junction. Diffusion current at emitter junction. At emitter junction. Next, IPE or IPC, whole diffusion current at collector junction. Diffusion current at collector junction JC. Okay, these are the main components. Okay, IR is recombination current. Okay, recombination current. recombination current. Clear? So these are the main current components present in a transistor. Now from these components I am going to deriving some equations. See this. See, deriving current equations means just I am applying KCL, not more than that. The first equation what I am applying is, see, with respect to transistor, this transistor is treated as, seems to be a node. Transistor seems to be a node. Now emitter current is entering, base current is entering, collector current also entering. So we can write the first equation, we can write from this one is IE plus IB plus IC equals to 0, because three currents are entering into the node. Three currents are entering into the transistor. Emitter current plus base current plus collector current. These three currents are, sum of these three currents is 0. Okay. IE plus IB plus IC equals to 0. Next one. Now, just I am applying KCL at this node. Now at this node, emitter current entering, IPE leaving, INE also leaving. So the second component is emitter current is written as IPE plus INE. IPE plus INE. Okay. And third one is I am applying KCL at this point. At collector terminal. At collector terminal, towards collector terminal IPC is there. Away from collector terminal IC naught is there. Similarly towards collector region, this point IC is there. Now IC IPC both are entering into this point and IC naught is leaving. Therefore third one is IC plus IPC equals to IC naught. IC naught. Therefore IC is minus IPC plus IC naught. Minus IPC plus IC naught. Okay, these are the main components. You should be thorough with this. Okay, now to define the performance of a transistor, to represent performance, I am going to defining few parameters. In that, first parameter is emitter injection efficiency or emitter efficiency. So next slide I am taking this. So first one is emitter injection efficiency. Or emitter efficiency. Emitter injection efficiency or emitter efficiency. Okay, now I am representing this one by a parameter called gamma. Okay, and it is represented by gamma star. So its value is, just with respect to emitter, let us take this is your emitter. For your emitter, the entering current is IE. Okay, the majority of the leaving currents from emitter is IPE. The majority of the current leaving emitter is IPE. Okay, sir. Now, gamma star I am going to representing as, that means emitter injection efficiency or emitter efficiency defining as output current IPE by input current IE. Output current IPE by input current IE. And we know the emitter current IE value. So we know IE value. So IE is IPE plus INE. Just before we've written that one. Therefore gamma star is IPE by IPE plus INE. So we can write it as 1 by 1 plus INE by IP. And one more thing here, you observed or not, emitter is heavily doped. So emitter is heavily doped. We know that. From transistor construction we confirmed that emitter is heavily doped. Heavily doped. So once emitter is heavily doped, we can write IPE is much greater than INE. So INE by IPE is very much less compared to 1. So in that case, it can be written as approximately 1. Okay, if gamma star is much close to 1, that means your emitter efficiency is very high. Emitter is effectively emitting large number of majority charge carriers. That is the meaning of that. Okay, this is about your emitter injection efficiency or emitter efficiency. The second one is phase transport factor. Phase transport factor. Okay, it is represented by beta. Phase transport factor. Phase transport factor represented by beta star. Okay, now I am taking the base part only. Base terminal of your transistor. Base. From base, once IPE is entering, okay, in this IPE, some part is going to be recombined at base in the form of IR. Remaining part is reaching the collector as IPs, and it is IP. So IP is entering, IPC is leaving, and IR is the recombination current. Okay, now so with respect to base is taking 100 carriers, 5 carriers are recombined, it is transporting 95 carriers. So this is the current due to 100 carriers, this is current due to only 5 carriers approximately, this is current due to 95 carriers approximately, sir. For your better understanding purpose I have written this. Now base transport factor is defined as beta star is IPC by IPE. IPC by IPE. IPC by IPE. That is the beta star. Okay. Now, already we know that IPE value. IPE value is IPC plus IR. So, from this we can write IPE is IPC plus IR. Just take that value, substitute here. Therefore, it is IPC by IPE is IPC plus IR. So it is 1 by 1 plus IR by IPC. Just before we mentioned here, IR is the due to 5 current is the due to 5 number of 5 charge carriers, and IPC is due to 95 charge carriers. That means IPC is much greater than IR. So IR by IPC is much less than 1, therefore its value is approximately 1. So if you are taking idea, approximately the value is 1 in this sense, your base is effectively transporting or exporting the charge carriers. Okay, now this is the second parameter, and the third parameter is large signal current gain. And in this, just we observed your transistor is operating in common base configuration. That means a base is common to both input and output. Emitter and base are at input side, collector and base are at output side. So base is common. So that is common base configuration. Now I am taking large signal current gain. large signal current gain. Large signal current gain. So for large signal current gain, here we can write alpha is, it is represented by the parameter alpha, which is minus of change in output current by change in input current IE. Now I am going to representing the equations what you derived previously from step 1 and step 2. Whatever the equations we derived, I am placing all these at one point. This is the type of current, emitter current or collector current. Okay, so here I am writing collector current and here I am writing emitter current. Now, so this is a type of current, and here I am writing in step 1 and in step 2 what we get. Type of current, first I am taking the input current IE, second I am taking the input current, output current IC. In step 1 emitter current is 0, first because emitter is open circuited in step 1. In IC is we got IPC. From result of step 1 we got IC is IPC. Just I will show you. See, this result is emitter current is 0, result of step 1, and IC is IC naught. Now after result of step 2, these are the current values. IE not equals to 0, IE having some value, and IC is minus IPC plus IC naught. Just I am going to taking these values. So IE is not equals to 0, not equals to 0. That means it is having some value IE, and IC is minus IPC plus IC naught. Okay, now just I take this substitute here. Now we can write this is minus of IC2 minus IC1 by IE2 minus IE1. IE2 minus IE1. So now its value is minus of IC2 value, this one, minus of this. So minus of IPC plus IC naught minus IPC by IE minus 0. Now it is plus, see this, it is minus of sorry sir, it is we got IC naught sir, this one, I am very sorry, this is IC naught. Go back, change that. Yeah, IC is IC naught, not IPC, IC naught. Sorry, by overlook I have written that. I am very sorry for that. It is a IC naught. So this is IC naught. Okay, now it is minus into minus plus. So it is plus IPC minus IC naught plus IC naught by IE. So minus IC naught plus IC naught will cancel. Remaining is IPC by IE. Therefore it is IPC by IE. This is large signal current gain. Okay, now whatever the three different parameters I derived so far, I am placing all these parameters at one point. Okay, now the first point is emitter injection efficiency, that is we call it as gamma star. We got this value is IPE by IE. Second one is beta star base transport factor, its value is IPC by IPE. Third one is large signal current gain alpha, that is IPC by IE. So just here I am going to multiplying these two, beta star into gamma star. Just multiply this. IPE by IE into IPC by IE. IPC by IPE. Now this IPE gets cancelled. You get finally IPC by IE. But IPC by IE is nothing but a alpha. It is nothing but alpha. So from this we can write alpha is nothing but a beta star into gamma star. This is the another equation for alpha. Okay, now I am taking this alpha. I am concentrating on this alpha. Now we know alpha is IPC by IE. Okay, now we know the collector current equation. We know collector current just before we written IC is minus IPC from IPC plus IC naught. From this I am writing IPC is alpha times IE, alpha times IE, alpha times IE. Now take this value, substitute here, therefore IC is minus alpha times IE plus IC naught. Sir, this is one of the important equation in transistor. This is the output current equation of transistor in common mode configuration. This output current equation of transistor in common base configuration. Output current equation of transistor in common base configuration. So in common base, output current is IC, input current is IE, and alpha is the current gain and IC naught is the leakage current. Okay. Okay, sir. This is about CB output current equation, common base. Similarly, I am going to deriving the current equation for in CE configuration, output current equation in CE configuration. Now see this. Just before we derived one equation, that is IC is equals to minus alpha into IE plus IC naught. But we know one thing from transistor, IE plus IB plus IC equals to 0. IE plus IB plus IC equals to 0. Okay. So once IE plus IB plus IC equals to 0, we can write from this IE equals to minus of IB plus IC. Take this one, substitute here. Therefore, IC is minus of alpha into IE. IE is minus of IB plus IC plus IC naught. Now it is IC is alpha into IB plus alpha into IC plus IC naught. Okay, plus IC naught. Just take this alpha IC this side. Now our equation is IC is alpha times IB plus alpha times IC plus IC naught. Just take this one this side. Therefore, IC minus alpha times IC equals to alpha into IB plus IC naught. Now, just take IC common from this. IC into 1 minus alpha equals to alpha into IB plus IC naught. Therefore, we can write IC is alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into IC. This is the another standard equation for output current equation of transistor in CE configuration. Now, I am defining another parameter here now. So this is your IC we derived. IC is alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into IC naught. Now I am taking let alpha by 1 minus alpha equals to beta. Now for my easy purpose I am adding 1 on both sides, alpha plus 1. This is our equation. Both sides I am adding 1 to this. Now by adding 1 to this, it is alpha plus 1 minus alpha by 1 minus alpha equals to 1 plus beta. So these two gets cancelled. Therefore 1 by 1 minus alpha became 1 plus beta. So you can replace this one by beta and you can replace this one by 1 plus beta. Finally, after replacing all these things, we can write IC is beta times IB, beta into IB plus 1 plus beta into IC naught. This is the transistor output current equation in CE configuration. Because in CE, we know the transistor symbol. This is NPN transistor. Collector, base, emitter. CE means emitter is common to both input and output. So this is the common terminal. Now the input is IB. Here output is IC. Output is IC. Now IC output current in terms of input current base current. So IC is beta times IB plus 1 plus beta times IC naught. Okay. So my dear students, here you need to keep one important thing in your mind, that is always output current should be represented in terms of input current plus leakage current. So this is the leakage current in this configuration, CE configuration. Okay, so we called it as I leakage current in common emitter configuration. Under third terminal base is open circuit. Later, these are the two special currents we have, IC E0 and IC B0. Later we discuss in detail about that. Okay, leakage current in common emitter configuration is IC E0. That is IC E0 value is 1 plus beta times IC0. Anyway, this is our final standard equation. This equation is very, very important to bias your transistor. Completely we are depending on these equations. And to understand your biasing effectively, first you should know about CE characteristics of your transistor. Okay, transistor CE characteristics. So before going to that CE characteristics, what I am going to do is, first I am going to taking the one parameter, one important topic I am going to discussing, that is a base width modulation. Base width modulation. This is very important topic. So let us, I am taking the transistor. Transistor. Now okay, emitter, base and collector. Sir, for better understanding purpose, I taken the width of the base little bit wider. Base, collector, fine, emitter. Okay, this is okay, whatever the transistor you can take NPN or PNP, it's not an issue. But this is emitter junction. Emitter junction is a default forward bias. Okay, when it is forward bias, no need to worry about depletion region width. Okay, now fine. And one more thing, we know emitter is heavily doped, base is lightly doped, and collector is moderately doped. And if you compare the doping levels of collector and base, collector is doped more compared to base region. Under open circuit condition, you can expect some depletion region. That too, the depletion region is extended more towards lightly doped base region compared to collector region. See, this depletion region extension is low at collector side and more at base side, because base is lightly doped. Now when it is going to be biased in reverse biased, here is VCB, reverse biasing. I am increasing VBC value I am going to be increasing here. Okay, this is VBC. So when it is going to be reverse bias more, increasing reverse voltage, so depletion region width at the collector junction is increasing. That too, because of low doping in base, it extended more towards base region compared to collector region. Now the depletion width is extended more towards base region. This is the depletion region width at base, and this is the depletion region width at collector. Now this is the total width, depletion region width in collector, now in base region at present. Okay, now this is the net region available for recombination. This is the effective base width. So this is effective base width, WB dash. Okay, WB dash, effective base width, WB dash, effective base width. Is it okay, sir? Now from this, what we observed, by varying the applied reverse voltage, the effective base width is going to be varying. This change in effective base width with respect to change in applied reverse voltage is called base width modulation. Base width modulation. Now, this change in effective base width with respect to change in effective base width with respect to change in applied reverse voltage at collector junction applied reverse voltage at collector junction voltage at collector junction at JC is called base width modulation. Base width modulation. Base width modulation. This is base width modulation. Now, is there any advantage to me, or is there any disadvantage to me, or what are the different currents we have in our transistor? How these currents are affected? Simple thing. Once base width is this much, more recombination is there. Base width is decreasing, recombination is less. Instead of 5 carriers recombine at base, once base width is decreasing much value, now 3 or 4 carriers are recombined. So once the recombination is decreasing, base current is going to decrease. Now the first effect is base current is decreasing. Second, instead of 5 carriers recombine at base, only 4 carriers are recombined at base, let us. The remaining one additional carrier reaching the collector. So that means collector current is increasing. Collector current is increasing. Third one is emitter current. See, emitter current is emitter current what we have is a diffusion current. The emitter current crossing this junction is diffusion current. So the emitter current is directly proportional to concentration gradient of holes in N region, holes in base, dP by dx. Now this is your dx. It is going to be diffusing in base region. So this dx is nothing but a WB dash. By increasing applied reverse voltage, dx value decreasing. That means WB dash decreasing. Once dx is decreasing, IE increases. So therefore IE increases. These are the effects of base width modulation on different number of currents what we have. Okay, fine. So these are very important to understand the transistor characteristics. Now I am going to CE characteristics. So CE characteristics. You can take any characteristics, either CE, CB or CC. There are two types of characteristics. One is input characteristics, first one. Input characteristics. Second one is output characteristics. One is input characteristics and the next one is output characteristics. Input characteristics is a plot between input voltage and input current. plot between input voltage and input current, and it is a plot between output voltage and output current. It is a plot between output voltage and output current. Okay, so input characteristics is a plot between input voltage and input current, and output characteristics is a plot between output voltage and output current. And at input characteristics we are going to keeping input output voltage constant. At output voltage constant we plot this. By keeping output voltage constant we plot the input voltage and input current. Similarly here we are going to keeping input current constant. At input current constant, why we are keeping only these parameters are constant is, in H parameter analysis, your transistor analysis, you are using H parameter model. Why? Because H parameter values are real values at audio frequencies. And one more important reason to use H parameter in transistor is because of base width modulation. Because of base width modulation. In base width modulation, how the way parameters are varying and related to each other, the same way in H parameter different parameters are related. That's why H parameter analysis we are using to analyze the transistor amplifier, and we replace the transistor by its H parameter equivalent. Is it okay, sir? Now I am going to taking first input characteristics. Now for input characteristics, what is the input voltage and what is the input current? And the beauty in transistor is everything is visible to you. So my dear students, now I am going to telling an important point here. Now onwards, the transistor, we are entering main part of the transistor. Now everything is visible to you, in front of you. Just you need to pick the right value. That's it, not more than that. Everything is visible to you. Now first I am going to that. First we are going to input characteristics. Input characteristics. Input characteristics. Now, so we are taking CE, that means transistor should be in common emitter configuration, CE. So here emitter is common, input terminal should be base, output terminal should be collector. So emitter is the common terminal. This is the step 1, common terminal. This is the step 1. Everyone should follow this procedure. Then only you can easily understand the things. Now, there is a voltage between input terminals, base to emitter. Base is the main terminal. So input terminal is base, output terminal is collector. Emitter is common terminal. Now there is a voltage between at input side, that is VBE, because base is the main terminal, emitter is common terminal. Similarly, there is a voltage at output, that is VCE. VCE is the output voltage. And similarly, there is an input current IB. Base is the main terminal. Similarly, there is an output current IC, because collector is the output terminal. Everything is visible. Okay. Now the 4 parameters we have from this, they are VBE input voltage, and IB input current, and output voltage VCE, and as well as output current IC. Now, in these 4 parameters, I am taking 2 parameters are independent and the remaining 2 parameters are dependent. Why? Because here I represented my transistor as a block box representation. The beauty of the block box representation is, from the knowledge of terminal characteristics, you can estimate the behavior of your system. Behavior of the system, what is present inside of the block box, we can estimate from the knowledge of terminal characteristics. That is the beauty of the block box. Okay. Now, so this is the two-port network. Here just I applied. By applying these two-port networks, we can estimate the behavior of the any system which is present in the two-port network, which is presented in the network as a network, by from the knowledge of terminal characteristics. Here are the 4 parameters. In this, I am taking 2 parameters are independent and the remaining 2 are dependent. Okay. Now, here these 2 are going to be represented as independent parameters. These are the independent parameters. You may ask one thing, sir, what is the meaning of independent? The meaning of independent is, now onwards, at input side we have VBE. So VBE is a function of these 2 independent parameters, input current IB as well as output voltage VCE. Okay, similarly, output current also a function of same parameters, input current IB, output current VC. So my dear students, don't get confused. No need to by heart anything. Everything is visible to you. Now, here, this is VB, fine. Now, we are going to using this one for input plot, input characteristics, and you can use this equation for this one for output characteristic. Okay. Now, you may ask one thing, sir, how can we use this one for input characteristics? Just a minute. The window is loading. So VBE is a function of, our equation is, VBE is a function of IB comma output voltage VCE. That means here is our transistor. Here is our transistor in common emitter mode. Collector, input side you have a base, and emitter terminal is the common terminal. Let us assume it as a ground. Now, these are the input parameters, input voltage VB and input current is IB. Okay, and already we mentioned input characteristics means it is a plot between input voltage and input current. It is a plot between input voltage and input current. This is the input current IB. This is input voltage VBE. See, everything is visible to you. No need to by heart anything. Everything is visible. Now VBE, IB. So VBE, IB. The remaining parameter in this equation is output voltage VCE. So now you need to plot these two by keeping VCE constant. That means now at constant VCE you are going to plot it. at constant VCE, you need to plot this. You may ask one thing, sir, what is the meaning of keeping VCE constant? Okay, first case, I will take VCE 0 and by varying the VBE, I will take the respective IB value. Second case, I will take VCE greater than 0. Okay, greater than 0. Okay, that means other value. So once VCE, we are changing the value of VCE. Again, we plot the, we take the, we vary the VBE and we take the respective IB value. Like that, we can take different, we can plot the different value. We can plot between this VBE and IB with different values of VCE. That is the input characteristics. Okay, so here we are taking VCE. So, and one more thing, sir, this is NPN transistor we are using. So now we go and draw the input characteristics of transistor. Okay, now I'm going to draw it. So this is the plot. This is the plot. This is the IB, input current, and this is the output VBE, sorry, input voltage VBE. Okay, now first plot, I am plotting at V output voltage VCE equals to 0. VCE equals to 0. Practically VCE 0 means you need to do both short circuit. See this circuit. So I am taking the transistor like this. Like this. Let us take NPN transistor we are using here. Base, emitter and collector. Okay. Now this emitter, this is our emitter junction and it is collector junction. Emitter junction should be in forward bias. Okay, I am connecting this in forward bias. So forward bias means a VBE you need to apply positive, negative. Like this. So this is the voltage VBE. VB. Once VBE is varying, the current IB entering into this also varying. More forward voltage, more forward current we get, because that is similar to PN junction. Now I am going to taking output side. At output side, now this is your output voltage VCE. Here you have VCE. Okay, now I take VCE 0. First, for better understanding purpose, what I am doing is, first I am going to open circuiting output voltage. Output is open circuiting. First open circuiting output. Next we take VCE 0. Step 1 is output open circuit. Under output open circuit. Open circuit. Once output is open circuit, there is no voltage we are applying between these two. Now it is similar to the P connected to positive terminal, N connected to negative terminal, similar to forward biased PN junction diode. Forward biased PN junction diode. Is it okay, sir? Sir, is it okay? Forward biased PN junction diode. So we know the plot of forward biased PN junction diode, plot, VI plot. Now I am going to plot this. Yeah. So this is the forward biased PN junction diode VI plot. Like this. It is increasing like this. Yeah. Like this. This is step 1. This is the plot for step 1. Second case, what I am doing is just I am going to taking VCE 0. Okay, you need to compare both the steps. That's why I am going to keeping the diagram as usual. I am taking another diagram because we need a comparison. That comparison is very much required here. Step 2. Okay, let us take step 1. Now in step 2, I am taking VCE output voltage. What you have is 0. I am taking. So VCE 0. Fine. So first I am drawing the transistor. What we have. So this is the transistor. Yeah. Now yes. Say this. Okay, now it is we know that it is a NPN transistor. NPN transistor. And this is VBE what you are applying. VBE. And it is seems to be a forward biased PN junction diode. This is the base current IB. And this is the VCE we applied. So VCE. Now what you are saying is VCE should be 0. Okay, I am making VCE 0 means simply short circuit. Once VCE is 0, you observed or not, whatever the negative terminal of VBE we connected to this, negative terminal we connected to this, the same negative voltage is going to be forwarded from here to here. Same negative voltage forwarded to this collector terminal. It is collector terminal. It is emitter terminal and base terminal. You know that. Now once collector is negative, what I am expecting is whatever the whole electrons present in, see this, sorry, negative terminal, whatever the electrons is, they are repel this. Now whatever the holes available in this, whatever the holes available in P region, they are going to be attracted towards that side. Okay. Now once holes are attracted, less number of carriers are crossing the junction. Previously, if 100 holes is there in this base region, let us assume 100 holes cross the junction. Due to that 100 holes, you get the current. Now but due to this negative, few holes are attracted towards this. Okay. Now holes which are available are going to be, few of the holes are moving this side. Few holes. Okay. Once few holes are moving that side, now the resultant carriers, resultant holes crossing the junction is less than the previous case. For example, previous case, in this case 100 holes cross the junction, 100 holes cross the junction, let us assume. But in this case 90 holes are only crossing the junction, because this negative charge, negative polarity on this collector terminal attract the holes which are present in the base region towards this. So these holes are not crossing this emitter junction. Your base current is due to, now your base current is the current which is flowing like this. This is your base current. Okay, that means your carriers should flow in this direction, but they are moving away out of it. That's why your base current is decreasing. Therefore, base current is decreasing. That means, no, you may ask one thing, sir, what is the meaning of decreasing in base current? Simple thing, sir. Previously, at this voltage, you got this much base current, this much base current. Now, at the same voltage, you get less than this base current, less than this base current. Somewhere here you get. At this voltage, previously you got this much base current, now less than this. Like this, every point is going to be shifted down. Now your plot is like this. This is going to be the plot. Now this is the plot in second case. That means at VCE is equals to 0. At VCE equals to 0. Now I am going to taking the third condition. That means I am taking now VCE greater than 0. Third step. Third one. VCE greater than 0. 0 volts. So now I am taking transistor. So base, emitter and collector. Emitter and base. And NPN transistor. So it is PBE positive. This is emitter current, sorry, it is base current. Now we need VCE greater than 0. VCE greater than 0. Now a voltage I am connecting here, VCE greater than 0. VCE. Voltage between collector to emitter. Now once VCE greater than 0, what happens here is, see this. Now collector terminal connected to the positive, that means it became positive. So due to this positive voltage, your collector junction, what you have, it became reverse bias. So once collector junction is under reverse bias, the depletion region at collector junction is going to be increasing. It results the effective base width is going to increase. So now I am representing the same thing here. Therefore, once VCE greater than 0, collector junction became reverse bias. Collector junction equals to reverse bias. Once collector junction is reverse bias, effective base width decreases. Depletion region at collector junction increases. So depletion region at collector junction JC increases. It results, once depletion region width at collector junction increases, the effective base width is going to decrease. Effective base width is going to decrease due to base width modulation. That means depletion width is more extended towards lightly doped base region. That is the reason. So the effective base width is decreasing. WB dash. So this is nothing but a base width modulation. We know that. Base width modulation. This is. Is it okay? Once base width modulation is taking place, already we know once base width modulation is taking place, your base current is going to decrease. That is what we need. Base current is decreasing. So the resultant of base width modulation is base current is going to decrease. Now I am going to representing the same thing on this plot. So now here the base width is base current is going to decreasing. So here is your base current decreasing. Base current is decreasing like this. Sorry. Like this. This is the third case. Now, first case is output open. Second case VCE 0, output voltage VCE 0. That means output short circuited. Third case VCE greater than 0. Okay, now from this we observed by moving step to step, so your plot is moving away from it. Plot is moving towards right side in this sense, your base current is going to decrease. Okay, so this is at under open circuit condition. This is at VCE is equals to 0. Now this is at VCE greater than 0. This is at under output open circuit. Okay, so this is the variation of various plots for this is CE input characteristics. Now so far we know what is the reason why your plot is moving away from it. Okay, we know everything. So we know everything. So if you understand this slide effectively, then CE characteristics is completed. Okay, for every step, what happens at the junction, what is our transistor, everything I placed in a place as a diagram. Okay, next we move to output characteristics. Now I'm moving to output characteristics. See, now let us, I am taking transistor in CE case, CE model. Just before we applied two voltages to this transistor, VBE and VCE. See this, VBE we applied as well as VCE we are applying. We are applying VBE and VCE. But if you observe your transistor, there is a junction, one PN junction at emitter to base, another PN junction at base to collector, from base to collector. Okay, from the knowledge of VBE, I can easily understand P connected to, for this emitter junction, base emitter junction, P connect, this is NPN transistor, sir, for your kind of information. P connected to the positive, N connected to the negative. Therefore, base emitter junction is always forward bias. Fine. Therefore, VBE greater than 0. That it means always emitter junction is forward bias. Always. Okay, let emitter junction is forward bias we are taking. That is a default one, because in except cutoff remaining regions we need to take that one greater than 0. Okay, and if you observe this, we don't know the region of operation of this collector junction. With VB I am going to fixing the region of operation of this base emitter junction, but I don't know the region of operation of junction between base to collector. Okay, if I know the voltage between base to collector, from the knowledge of that, I can easily identify the region of operation of that diode also. Now let us, I am taking this is positive and this is negative, and I am taking this voltage is VBC. So if VBC is positive, then this collector junction is forward bias. If VBC is negative, then this collector junction is under reverse bias. Now I am writing that point. See, if VBC positive greater than 0, it means your collector junction is under forward bias. Second one is, if VBC is less than 0, now your collector junction is reverse bias. Okay, now you may ask one thing, sir, we are not applying any voltage between base to collector, then how can you get that voltage VBC? See, we are not applying any voltage between base to collector, I am also accepting that, but we are applying the voltage between base to emitter and collector to emitter. These two voltages are sufficient to get the value of VBC. Just to see this. Now we can write VBC is VB minus VC. For better understanding purpose, VB minus VC. For easy understanding purpose, what I am doing is base collector is there, emitter is missing. Just add VE and subtract VE. Now I am writing this one in a different way. Therefore, VBC equals to VB minus VE. This one minus this one. Next, minus VC minus VE. Now finally you get the same thing what you applied here. Now VBE can be written as VB minus VE can be written as simply VBE. We know the value that was what we are applying at input side, minus VCE is nothing but a VC minus VE is nothing but a VCE. So this is the another input, another voltage we are applying in transistor. So from the knowledge of two voltages what we are applying, VB and VCE, we can get the knowledge of VVC. Now from this I am going to be finalizing this. Say this. So you know VC greater than 0, what happens? Collector junction forward bias. Emitter for VBC less than 0, JC collector junction became reverse bias. Now I am going to representing this one and this one. I am going to combining these two and I am preparing the things. Now so our VBC is VBE minus VCE. So our VBC is equals to VBE minus VCE. Fine. Step 1. If VBE greater than VCE, then what happens? Once it is greater than compared to this, now it became VBC is greater than 0. Once VBC greater than 0, collector junction is under forward bias. Similarly, if VBE less than VCE, because we are applying VCE also. In that case, VBC less than 0, because this is less, this is more. Now under this we can write collector junction is reverse bias. So this much knowledge is sufficient to plot output characteristics of a transistor. And just I am taking 1 minute back to this main equations. See, if you observe the equations here, so now the output current equation is IC is a function of IB and VCE. Now I am going to taking that. See this. Therefore, we know output current is a IC is a function of input current IB and output voltage VCE. Okay. Now, see this. Here, to plot the output, this is the output plot. So this is the output current. It is a plot between output voltage and output current. Output current is IC and output voltage is VCE. VCE. Output voltage is VCE. Now, at constant base current, you need to plot it. At constant base current, you need to plot it. Therefore, this plot is at constant base current. At constant base current. IB. Okay. At constant base current. Fine. Now I am taking transistor in CE. So it is emitter, it is a collector, base. So by applying a constant VBE to this, I am going to keeping a IB constant. Let us, by applying some VBE, I am keeping IB constant. Now by varying VCE, what is the variation of IC I want to get? That is my plot. First, let us, I am going to taking step 1 is I am taking IB equals to 0. First case. Current is 0. IB equals to 0. Once IB equals to 0, what is the variations taking place in that? First we need to identify that. See carefully. Sir, once IC is equals to 0, sir, IB 0. IB 0 means once you open this voltage, if you are not applying any voltage between these two, then IB equals to 0. That is one step. And by connecting this VBE 0 also, you can make out IB 0. Why? Because to make this is our NPN transistor. To make this base emitter junction off state, I'm not saying about forward or reverse bias, off state, potential between these two is equal, then it is off state. To make this junction into on state, now potential at P terminal should be greater than minimum 0.7 compared to potential at N terminal. Okay, so you by taking VBE equal to 0 also, you get IB 0. Now you may ask one thing, sir, why don't I take VBE open circuit? By open circuiting the terminal directly IB equal to 0, that is very easy to me. It is very easy to you, fine. But VBE open terminal, in this sense, VBE is infinity. That is the meaning of that. Okay, resistance between that one is infinity, base to emitter. You are not applying any potential means. Now, but I want to continuously compare VBE and VCE. So to place this VBE, where can I place this VBE? Where can I place this VBE value on this VCE plot? Because I want to compare every time. So not possible that. Because of that, to make IB 0, simply first you take VBE 0. By taking VBE 0, we are going to comparing this. Fine. Now, first I am taking VBE 0. Once taking VBE 0, now that means your VBE value is somewhere here first. So your VBE is 0 here. This is your VBE, 0 volts. Once VBE 0, now once 0 plus, VCE is 0 plus, VCE 0 plus, now it is negative, VBC became negative. So here for VCE greater than 0, VCE greater than 0, VBC is less than 0. So we know once VBC less than 0, collector junction reverse bias. and we observed already in reverse bias, once junction is under reverse bias, okay, your output current is constant. It cannot change with respect to output voltage. So with respect to output voltage, it is constant. Now I am going to plot it. So this is my plot. This is my plot. Here output current is constant. This is the case at IB equals to 0. IB equals to 0. Okay, next. Second step I am going to apply. Second step. Second case. At second case, I am taking IB is not equals to 0. That means I am taking IB equals to IB1. To get IB equals to IB1, you need to apply VBE equals to VBE1. Let us I am applying VBE1. Now I got current IB1. Fine. IB1. So you need to compare every time VBE with VCE. Now let us I am going to taking that comparison. So I am going to placing this VBE on this plot. So somewhere here is your VBE1. VBE1. That means during this region, after this, and they are dividing this one into two regions, sir. From here to here, to here, what happens? VBE is greater than VCE. Once VBE greater than VCE, VBC greater than 0, collector junction is in forward bias. Now in this region, collector junction is in forward bias. From here to here, collector junction is forward bias. Next, after this, VCE is greater than VBE. So here VCE greater than VBE. That means VBC less than 0. I am writing directly that. Here VCE less than 0. Once VCE less than 0, it means collector junction is in reverse bias. Once collector junction is under reverse forward bias, current is increasing with respect to voltage. And after that it is in reverse bias, so current is going to be constant with respect to voltage. This is the case for IB1. This is the case for IB1. Similarly, now I am taking IB2. For IB2, you need to apply VBE2. So somewhere here, my VBE2 is somewhere here. So this is the divisional. Now here during this, VCE is less than 0, and during this VCE is greater than 0. That means during this period, collector junction is under forward bias, and during this region, collector junction is under reverse bias. Once it is under forward bias, current increases with voltage. Current increases with voltage like this. After this, current is constant with respect to voltage. This is IB2. Okay, so you get the plots like this, and you observe one thing. These are the points from where your transistor switching from, your collector junction switching from forward to reverse. So that means now I am going to drawing this plot once again for better understanding purpose. Now we need this plot. So my dear students, this plot is very, very important. So this is IC, collector current, output current. This is VCE. First we observed for IB equals to 0, we draw the plot. Now your first plot is like this. Your first plot is like this. Second plot for IB1. So your plot is initially up to here, it is forward bias. After that it is reverse bias, collector junction. Third plot, up to here forward bias. From this it is reverse bias. Similarly, fourth plot. Like that, at different values you get different things. Like this. Okay. Now, these are the points where your transistor, your collector junction switching from forward to reverse. Forward bias to reverse bias. Now, just I am dividing this. Like this. If you observe one thing, here it is IB equals to 0. It is IB1, IB2. Now let us, I am taking this is IB minimum. I will explain next why it is I taken IB minimum, because IB is already 0 microamps we taken. So don't forget units, sir, they are microamps. Okay. Why I taken this is IB minimum, next I will explain. See, now in this IB0 means current through emitter junction is 0, base emitter is 0. No current is flowing between base to emitter. So when your junction is reverse bias, then only no current is flowing through the junction. So it can be treated as emitter junction also in reverse bias. By default of VBE 0, VCE greater than 0, collector junction also reverse bias. Now this is called cutoff region, because both the junctions are reverse bias. Cutoff region. After this, after IB0 plot, emitter junction is greater than 0. That means emitter junction is forward bias because of some base current. Some base current you have, in this sense, emitter junction is forward bias. Emitter junction is forward bias. At the same time, here we observed collector junction is reverse bias. Because of collector junction reverse bias only, your collector current is constant with respect to applied voltage VC, output voltage. Okay, in this region, here also base current not equals to 0, greater than 0. That means your emitter junction is in forward bias. So emitter junction is forward bias. And at the same time we observed collector junction also forward bias. Because of that only, with respect to output voltage, current is increasing. So this is the region. This is the region. Now we know that when both the junctions are forward bias, we called it as saturation region. Now emitter junction is forward bias and collector junction is reverse bias. We called it as active region. So from this output plot, we defined whatever the three regions we have. Okay, whatever the three regions we have, we defined all the three regions. Okay, we defined all the three regions here: saturation region, active region, and cutoff region. Inverted region practically we are not using. So my dear students, please be concentrate on this. Now we have one more point left, that is IB minimum. Why IB is taken minimum? Why I represented IB minimum is, this is the minimum amount of base current required to a transistor to switch from active to saturation. To switch from active to saturation. Active to saturation. To switch a transistor from active region to saturation, minimum this much base current you need to provide. That's why with respect to active and saturation regions, I named it as IB minimum. This is the output characteristics of the transistor. So my dear students, this is very, very important to you. Okay, in transistor biasing, this characteristic plays a vital role. Please don't forget. Please be concentrate on this. Okay. Now, this is our today's topic. Now, I am thanking to one and all for spending your valuable time with me. Okay. Don't forget to use my code VRAW10 during subscription. By using my code VRAW10 during subscription, okay, you get 10% discount. And please subscribe us. Don't forget. Join our Telegram group to get the latest updates on our upcoming videos. And please hit the bell icon for getting the notifications. Okay, please give your valuable comments on YouTube to strengthen ourselves and to provide a better and quality information to the students who are coming. Now, once again, I'm welcoming you all to this India's largest online learning platform, Unacademy. Thank you very much. Thanks for spending your valuable time with us. Thank you.